Welcome back to LundX. That is a guide for you. Make your research simple. Today we will learn about primer and how to design it using the NCBI database. What is primer? Simply we can say a short single-stranded piece of DNA. We can say a starting point for DNA synthesis. In addition to this, we can also call it as a starting signal for DNA polymerase enzyme to start amplification. Without these starting signals, DNA polymerase enzymes cannot start amplification. Why we need to design primer? Because we want to target a specific piece of DNA. Why we use primer in qRT-PCR? Simply we can say for quantification, to amplify and measure how much of a specific mRNA is present. In qRT-PCR, what does primer do? Primers guide DNA polymerase enzyme to replicate the cDNA region between forward and reverse primer. What happens in qRT-PCR? In the qRT-PCR, the amount of cDNA is being monitored cycle by cycle, and during this cycle by cycle, primers ensure the amplification of a specific gene is being occurred every time. How does qRT-PCR work? It starts with denaturation, followed by a reverse and forward primers point to their specific target, and then polymerase enzyme start to extend this amplification. So therefore we need to design primer. We need to keep some features when we are going to select a primer. Just like a primer length should be in between 18 to 25 base pair. Guanine and cytokine content should be 40 to 60%. Melting temperature ideally is 60. It should be in range 58 to 62%. But both primers should have a similar melting temperature. Variation may occur just like 1 to 2 centidegree, not more than 1 to 2 centidegree. Amplicon size, it should be 70 to 200 base pair. Now question is that what happens if these features are not appear in our primers? If we are look at primer length, if primer length increases, then a recommendation, the efficiency of amplification decrease, dimmers may appear. If guanine and cytokine content increases more than 65%, hairpins may appear. Strong secondary structure may be caused. Melting temperature if increase, binding will not be proper. Mismatch with pair may occur. Amplicon size if more than 70 to 200 base pair. Low amplification occurs. Poor efficiency. These problems can be faced if we ignore the features or characteristics of primers during selection of primer. So now let's start how to use NCBI to make a primer. We need to write NCBI database, and here now we need to select a gene. After that we need to write a gene name, just like I want to search WNT4. After gene name we need to write the scientific name of a species, just like I am going to search WNT4 in mouse, so I need to write scientific name of mouse. After that you need to click search. Now here, if we look at this, here is the species name, here is the gene which we search, and here is the full name of the gene. So let's click this one, or you can also click this one, it is not a big issue. After that we need to go down. We need to locate the mRNA. So here we need to click this one. Now here there are three ways to design a primer, just like if we look at FASTA or RunBLAST or pick primers directly. So if we click as a FASTA, here you can select a specific part of this gene on your choice. You can run BLAST, and here you need to give some specification from which to which size, just like, and here you need to give some details. Here you need to mention a species name, but usually I select direct pick primers. When you click pick primers, automatically parameters selected as a default, okay, is already a species is being selected because we already mentioned mouse species. So this is, and after that we need to click show results in a new window, and then we click get primers. Now it has been started, just like in new window. Now if we look at the status, current time, and it is being primer, it is being designed, so we need to wait, and once finished we come back. Now let's check. Okay, it has been completed. Series of primers has been designed for us. Now the problem is which one among these all primer is suitable for qRT-PCR. So as we already mentioned, some of the features we need to keep in mind. If we look at the product length, primer 1 his product length is more than 600, but the most suitable is 70 to 200. In addition to that, we didn't mention complementary. Now complementary was what? Self-complementary. Self-complementary refers to how much a primer can bind to itself due to internal base pairing. High self-complementary can lead to undesirable structure like hairpins or primer dimmers. Usually recommendation is less than 4. So if we look at self-complementary is less, but product length is little bit higher. So if we look at second primer, here is also product length is little bit higher. Third, it's more than 600. Fourth, product length is ideal, it's within range. If we look at melting temperature, it's also ideal. GC percentage, it's also within range. But self-complementary, if we look at here, forward primer as well as reverse primer have a higher self-complementary. So we need to look others, just like this is a primer pair 4. Primer pair 5, it's also product length is little bit higher than recommendation. In addition to that, if we look self-complementary is 5. 6, if we look primer product length is little bit more than 400 and self-complementary is little bit higher. If we look at primer pair number 7, product length is 132. Its ideal is recommendation is 70 to 200. So GC percentage is also both have same. I usually select the primer which has GC percentage in between 50 to 60, and melting temperature is also ideal 60. So, and self-complementary, if we look at 4 and reverse primer is little bit higher, but in comparisons to other, among these all there are 2 primers which are suitable for qRT-PCR, just like primer 4 pair number 4 and primer 7. Now we need to choose among these 2. Both are okay, but in case of 4 primer, self-complementary of forward primer also 6 and reverse primer is 5. But in case of primer pair 7, if we look at self-complementary is 4 and of forward primer within the range and reverse primer is little bit higher. However, melting temperature and GC percentage is ideal. So in such situation, in my case, I would like to prefer to select this primer. But 4 primer number 4 is also good because its product length is ideal. Because of this self-complementary and GC percentage which is very between 2, so I don't want to select this one, I need to select this one. So this is how we need to select a primer, and now we just select these and select the details of this and give to company for designing primers. So that's what we learn, how to design primer, and thank you very much for watching my video. Please, if it is helpful for you, kindly subscribe my channel for upcoming videos. Thank you.